Let's talk about the cubes now, and hopefully I had to move everything to get out of that glare, but I think I'm out of it. Okay, so we're going to talk about building up the cubes, and see, we have a broken cube here, and that's going to kind of also give us a hint as to how we could to build up the cube. So the problem we're trying to solve here is the number of different arrangements of these 2x2 cubes. Okay, yeah. And you can see it's going to be hard to tell. Like, is that arrangement different than this arrangement? I don't know, right? I mean, can we rotate it into this position?
If you check every single piece.
Yeah, you got to figure that out. So it's actually not so simple, right?
Yeah.
So how do you think we could count the number of arrangements of one of these cubes?
Well, when you have a cube, when you just have the center and no pieces on it.
Right. So all the pieces off here.
Then you can put one. You've got 8 spaces to put the 8 pieces in. Mm-hmm. So it's 8 choices for the first one.
Okay.
7 choices for the second. 6 choices for the 6th, and so on, all the way down to 3 times 2 times 1.
Okay, so it looks like we got 8 factorial, and we were talking about that with the snap cubes, and we found with the snap cubes that when they were all different, and I should probably make them all different if I'm going to point that out. If they're all different, 24. That was one thing, but if some of them were the same, that was another thing. So when we're building up the cube out of the pieces, are all those pieces the same, or are they all different?
All the pieces are different.
How do you know that?
Because it's a corner. Each piece is a corner.
Yeah, let's bring a solid cube in. Each piece is a corner, and you can tell which corner it is. None of the corners have all 3 the same. Okay, so that's good. But unlike our snap cubes, there's actually one extra little bit of complication.
Because you can make it unsolvable.
Well, you can, right. That's one complication, definitely. And the second complication is there's 3 different ways you can put a piece in. Let's go back to the solved cube. You can put it in, you can put this piece in like this. You can put it in like that. Or you can put it in like that. Okay? And then
But only one of those is solvable.
That's true. We'll get to that in a second. Only one of those is solvable. But so when you put the first piece of the cube in, you can put that in however you want, whatever rotation you want. But the next bit of the cube, when you put it in, you could put it in this way, that way, or that way. So for each of the next 7 pieces you put in, there's 3 arrangements. So we got to multiply by 3 to the 7th.
Whoa.
Do you understand why?
Yeah.
Because, see if you can explain it, because this is a fairly complicated.
Well, because the first piece, it doesn't matter how you put it in.
Okay, first piece, it doesn't matter.
You've got 7 extra pieces.
Okay.
And there's 3 different arrangements.
All right.
But only one of those is the real one that works.
Okay. And then one last tiny bit of complication until we get to the super complication is how many different arrangements are there of the cubes when I put them together? So how many different ways can I arrange this cube? These 2 are the same, right? They're solved. How many different ways can I arrange this cube that look like they're different than this but are in fact the same? Like, for example, that's looks different but in fact is the same.
You can move it 3 different ways on the y-axis, 3 different ways on the x-axis, and 3 on the z-axis.
It looks like it. So it looks like I can rotate 3 ways that are going to be different that way, 3 ways that are going to be different that way, and 3 ways that are going to be different that way. Okay, so how many ways do you think that ends up being?
Well, it would be 9 ways to rotate a cube.
It'd be 9. It seems like it might be 9 different ways to arrange that, but there's a problem with that argument. How do we know? How can we know immediately that there's not 9 different ways to rotate this and make it seem different?
Well, there's 8 pieces.
There's only 8 pieces. No matter how we rotate it, there's going to be a piece in this corner here. Say like this piece here.
Yeah.
In fact, let me rotate it through the same way. This red, green, white piece.
Yeah.
We can always just assume it's going to be in this corner. And there's 8 pieces we can rotate into that corner. All right? Do you see that?
Yep.
So in fact, the number of rotations is actually only 8. Okay. So we got to divide all this by 8 because each one of these arrangements has 8 ways to do the same. The other way we can think about this is we could start building our cube by putting this green, red, white piece in the corner like that, and then build everything else off of that. So we could put this piece in and it can be rotated 3 different ways, but there's 7 different pieces and 3 different ways to rotate it. The next one, there's 6 different pieces and 3 ways to rotate it. And that's how we build up the cube. Okay?
All right.
But there's one more thing.